Hello, dear students. I hope everyone is fine. Today, I'll be discussing on the preparation of amines. The first method, reduction of nitro compounds. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, and also by reduction with metals in acidic medium. Now let us see an example here, nitroalkanes. This is nitrobenzene. As we all know, reduction means removal of oxygen. Therefore, in nitrobenzene, the two atoms of oxygen atom will be removed and there will be addition of two hydrogen atoms. Therefore, this reduction can be done by palladium, platinum, nickel, hydrogen gas, acidic medium. As solvent, ethanol. As solvent, ethanol is used as the solvent, and it is a very good reducing agent, and therefore we get our amine here. Removal of two oxygen atoms with the addition of hydrogen atom is known as reduction. Therefore, nitrobenzene gets reduced to aniline. Now, another type of reduction can also be done using tin plus HCl or iron plus HCl. Now, so far, the reduction methods iron plus HCl. Iron using HCl is the best method for the reduction of nitro compounds. This is industrially applied. And also nitroalkanes can also be similarly reduced to their corresponding alkanoamines. Therefore, let us see it. This is a nitromethane. This is one carbon atom, so nitromethane can be reduced similarly using the same reducing agents to their corresponding alkanoamines. Therefore, the two oxygen atoms will be reduced and there will be addition of two hydrogen atoms. Now, let us see the second reduction method, that is the reduction of nitriles. Nitriles on reduction with lithium aluminum hydride or a catalytic hydrogenation, they produce primary amines. And this reaction is used for action of amine series, that is preparation of amines containing one carbon atom more than the starting amine. Preparation of one carbon atom more than the starting amine. Therefore, here is our nitriles, means nitriles 3 bonds. Now, this can be reduced. We can use lithium aluminum hydride or catalytic hydrogenation. Catalytic hydrogenation with platinum, palladium, nitrogen gas, nitrogen H2 gas. Now, this results in here two pi bond breaks up, and then here the definition is a reduction of nitriles means for action of primary amines. That means preparation of amines containing one carbon atom. Here, this carbon belongs to the nitriles. Therefore, in the our amines produced would have one carbon atom more than the starting amine. Therefore, this carbon atom, there will two bonds break. There will be addition of two hydrogen atoms, and then here also two hydrogen atoms, and two hydrogen atoms, one for carbon, two for carbon, and two for nitrogen. Now, we get here our corresponding amines. Two hydrogen is added to carbon, and two hydrogen is added to amine. Therefore, we get our corresponding primary amines. Now here we also use sodium mercury in the solvent ethanol. Now ethanol, as I've said earlier, this is a very good reducing agent. Now we will notice that in another reaction, Stefan's reaction, this reaction would be known as Stefan's reaction. Again, this reaction belongs to aldehydes and ketones. We will be discussing in the next unit. Now in Stefan's reaction, there is chloride plus HCl is used to get. However, in this type of in Stefan's reaction, only one bond breaks up. Therefore, only one bond breaks up, and then this is known as the resulting product is known as imine. Now in Stefan's reaction, only one bond breaks up, and then it gives imines. This results in partial hydrogenation, only partial hydrogenation, whereas in the reduction of nitriles in this method there is full reduction or full hydrogenation reaction is produced. Therefore, this reaction is known as the reduction of nitriles. Now let us check the third method, that is the reduction of amides. Okay, amides on reduction with lithium aluminum hydride, they give amines. Now firstly, what are amides? Okay, amides are the derivatives of carboxylic acids. Okay, in the unit for carboxylic acid, we will study that carboxylic acids are reduced by lithium aluminum hydride. Therefore, their derivatives, that is the amides, can also be reduced by lithium aluminum hydride. Carboxylic acids are this is a carboxylic acids. Now amides, therefore the derivatives of carboxylic acids, amides, this is an amide, this is a typical amide, and therefore now there is removal of oxygen and then addition of two hydrogen atoms will be added there, and this is known as reduction. Keep that in mind. And now on reduction of amides with lithium aluminum hydride in water, we get our corresponding two hydrogen is added with the removal of oxygen atom, and we get our amines. For every organic reaction, reduction reagents, the reagents used are very specific, and therefore since in the parent carbon in carboxylic acids, reduction is also done. A specific reduction is also done by lithium aluminum hydride. It is very specific for carboxylic acid, and therefore its derivatives, the amides, the reduction is also done by lithium aluminum hydride, and therefore this is very specific for every organic reaction. Now let us check the structure. Let us do the mechanism for this reaction. Now firstly, let us see what the structure for lithium aluminum hydride, because this is a specific reagent. The reagent itself here. Now in lithium aluminum hydride, let us see aluminum hydride. This is aluminum hydride. Now, aluminum belongs to group 13. Now we have here our lithium and hydrogen here. Now lithium is a donor and hydrogen is an acceptor. Therefore, lithium donates its electron to hydrogen. Therefore, lithiums become positive and hydrogen become excess of electrons. Therefore, it becomes negative. Lithium donates its electron. Therefore, it becomes positive, and then hydrogen would become negative. Therefore, the structure would be, now this hydrogen goes and adds up to aluminium. Therefore, the structure, our final structure, ALH 1, 2, 3, the fourth hydrogen atom goes ALH4 minus. Remember that the H minus is on hydrogen, and our lithium would be here. Now let us check the mechanism. We have our structure. This is our lithium aluminum hydride. Now the mechanism. This is our amide. nitrogen having lone pairs. Now, this hydrogen atom along with this bonding goes here, the bond pair goes here, and then goes and attacks the carbon atom. Since carbon is already tetravalent, it cannot be pentavalent, therefore one atom goes here. It goes and then now this remaining group goes and aids up to this carbon atom. Therefore, our structure would be hydrogen. The hydrogen goes and aids up here. This hydrogen is this, and then oxygen was here, and then Al, the 3 hydrogen along with aluminium, minus there was the electrons goes to electron. Now the nitrogen, the lone pairs goes here, and then there is removal of this group. Therefore, we would get here R, C, H, and H. Nitrogen would be partially positive, therefore removal of this H to H. Now, this allied hydrogen along with its bonding pair comes and attack the carbon atom, and therefore the carbon atom cause the bonding pairs cause to nitrogen again, and then we would get our amines. One hydrogen comes and attacks the carbon atom, therefore it would result in 2 hydrogen atom, and then this is our structure for our amines. Therefore, that is the mechanism